Hi, my name is Mark Grayston from Mitsubishi Electric, and I'm going to talk to you today about City Multi YLM, our pioneering new VRF product that we see as the ultimate heating and cooling solution for your building. When the factory were designing this piece of equipment, they went to look at the true fundamental building requirements. Firstly and foremostly, this piece of equipment needs to deliver comfort through heating, cooling and ventilation, and do it in a manner which uses the lowest operational running costs. At the same time, in this industry there is many legislations to adhere to, alongside ensuring CO2 emissions are kept to a minimum. Finally, and very importantly, the system has to be as easy to use as possible. So, introducing City Multi YLM, we see as the most advanced VRF system ever. The system has been completely redesigned in the thought process to configure it towards seasonal efficiency. We see a 27% increase in seasonal efficiency compared to the previous models. This is done in two key ways around the physical changes and controls changes. One of these changes is the heat exchanger. We've now adopted the use of an aluminium flat tube microchannel configuration. The controls changes, one around the cooling side to improve comfort, and around the heating side around the defrost cycle. This is a complete range change, so it includes heat pump, heat recovery, standard efficiency and high COP, all the way from 22 up to 140 kilowatts. One of the key design changes is around the focus towards seasonal efficiency against nominal efficiency. If you look at the cooling season, 35-degree ambient is where equipment was designed for nominal efficiency, and there's very little time spent at this point. Actually, in the cooling season, the majority of time is spent between 15 and 30 degrees, or in the partial load condition. The same thing is on the heating season. Previously a spot condition at 6 degrees, but actually the focus should be around the rest of the year between -5 up to 15. So gone are the days when we focus on that nominal EER and COP. Let's look at the seasonal efficiency across the whole of the year, the partial load efficiency, which relates to real-life run cost savings. To demonstrate the step changes in efficiency, let's look back at the previous generation product. In 2010 we had two variants, the P and the EP, which was 6% more efficient over an annual basis. In 2013 we launched YKM, a step again in efficiency, but with the introduction of YLM this year we see a true increase in efficiency again, leading to reduced running costs and reduced CO2 emissions. One of the key changes that you can make to a VRF system to improve the efficiency is the heat exchanger. A traditional heat exchanger has copper tubes and aluminium fins. It works really well, has done for years, and we use it still on the majority of our equipment. But with YLM we've been given the opportunity to try a pioneering new technology, being aluminium microchannel flat tube heat exchanger. Compared to a traditional round copper piping, not only is the surface area available for contact with the refrigerant increased, but the amount of passes which you can get in an area is increased from 3 to 4. This means there's much more contact within the heat exchanger itself. You get 17% more contact with the piping and 26% more contact with the refrigerant. So by having more contact between the refrigerant and the pipe and the fins, you get more contact with the fins and the air, making it easier to absorb energy and reject energy, therefore making it much more efficient. This is unique to the EP YLM models. Aluminium, why is this important? We see this as a unique pioneering step change in refrigerant distribution and heat exchange. And it's something that's a tangible improvement, not just a conceptual feature. But I might hear you ask, what about aluminium and corrosion? You typically get two variants of corrosion in aluminium. One is pitting directly through the material, and galvanic corrosion where one preferentially corrodes towards the other. We overcome this with a sacrificial zinc coating, which is covered all parts of the aluminium heat exchanger structure. This coating will sacrifice or corrode itself so that the aluminium underneath is protected, and it's been tested for an equivalent of 30 years. Yes, aluminium has some other benefits as well, but before I go into that I just want to highlight which modules are available. We have a small chassis, a large chassis and an extra large chassis, the height of which are the same as previous models, and the depth a little bit shorter. So if we now focus on the EP YLM models with the aluminium heat exchanger, the 200 and 250, 22, 28 kilowatt models typically used in hotel applications. These have gone down from an L chassis to an S chassis, meaning reductions in footprint, weight and critically refrigerant volume. Another one to focus on are the 400, 450 and 500, so 45 to 55 kilowatts. These previously were two L chassis, now a single XL chassis, meaning the reductions in weight and footprint are significant. Focusing on one in particular, the EP400 has 126 kilos reduction in weight. So if you imagine a few of those on a single project, the impacts on the roof structure are quite significant. More, there's even more benefits with aluminium, but this is not just the EP aluminium models, but also the P variant. A reduced refrigerant volume is critical for EN378 when looking at hotel bedrooms in particular. The product changes include the efficiency of the heat exchanger and its ability to absorb and reject heat, meaning the standing charge that comes with the unit is reduced. The factory have also managed to design the system so the amount of additional charge per metre is also reduced. And if we look at this in terms of a real application, we're looking at reductions in terms of 10% on a system compared to the previous generation product. And what this essentially means is we can either go into smaller bedrooms or we can have more indoor units on the same system, making it much more cost effective. And remember, there's always those leak detection systems which we supply, or the HVRF system. Other elements which have optimised the design in the VRF system firstly include the distribution of the refrigerant. This has been now designed so that the most amount of energy can be absorbed and rejected as possible. Secondly, standby power. So when the unit is off, the crankcase heater is now heated via an induction heater, reducing standby power by around 50%. Thirdly, the bell mouth grille, so where the air comes out of the unit. This has been redesigned to ensure static pressure is reduced to a minimum, and there's a new DC motor on the fan to ensure the power input to push that air is also reduced as much as possible. And finally, the new compressor. This has been completely redesigned, away from a peak load efficiency towards a partial load efficiency, meaning that the seasonal efficiencies are increased, running costs are reduced and CO2 emissions also reduced. So as well as those key physical changes, there's also been some key controls changes to improve the comfort whilst also saving energy. The first one of these is around the cooling side. Currently on the cooling side we have challenges sometimes in traditional VRF systems whereby the off-cool temperature is not quite high enough or it's not quite controllable enough. But with YLM we have two options to overcome this and improve the comfort whilst also saving energy. The first of the control features is around increasing and fixing the system evaporating temperature. The standard 0 degrees now has additional options of 6, 9 and 14 degrees. This gives typical air off temperatures from the indoor units from your 8 or 9 degrees Celsius through 10, 12, 14 degrees. And as a function of that, the SHF also increases. The total capacity, however, does decrease slightly, so you're looking at the balance between capacity and increased comfort from air off temperature. The second of the cooling control function changes is around automatically increasing the evaporating temperature of the system based on the internal load. What the system will do is it will monitor the set temperature and the inlet air temperature of the indoor units, and as the two get closer together, the system will automatically raise the evaporating temperature from a standard 0 up to 9 degrees. This function alone will increase the seasonal efficiency by an additional 8%. Considering this function in a real application, let's look at if we're using 21 degrees C as a set point, with our red line on the graph being the room temperature, an indication of the air off in the top right hand corner. So as the room is being cooled and it gets within 1 degree from set point, the system control will activate. As it gets closer towards set point, the evaporating temperature starts raising, the off-cool temperature starts increasing, and the capacity reduction is actually in effect. So what we're getting here as we get closer and closer towards the set point is an additional control function on VRF to deliver just what is required and deliver that in a comfortable manner. A side effect of this is when we're in this control area, the efficiency of the product is also increasing. The other key control side is around the heating element, and specifically the defrost cycle. Defrost is integral to a heat pump. It happens, it's just how we deal with it. We've always managed to deal with it very well, and this is still important with the new feature that YLM brings. Defrost will typically happen below 6 degrees Celsius, so it happens for a decent portion of time in this country. With YLM we have a choice between your standard reverse defrost and an optional hot gas defrost, whereby you're providing heat to the indoor units while the outdoor unit does its defrost. This new defrost technology is available in all YLM models: standard, high efficiency, heat pump, heat recovery, and single and multiple modules. The way it works is slightly different between a single and a multi-module. In a single module, the heat exchanger is split, defrosting one half whilst providing the other heat to the indoor units, and then rotating, and it will do this down to a minimum of 1 degree outdoor temperature. Below this, there's not enough meaningful heat to give to the indoor units to make it worthwhile. If it's a modular system, it will do one defrost module at a time, and it will do this down to a minimum of -5 degree outdoor temperature. The benefits of this new hot gas defrost function are that the system can deliver continual heat to the indoor units for a very long period of time, meaning there's less changes in fan speed and temperature, and capacity is actually delivered into that space for a continual period. So the perception of people sat in that space is it's much more comfortable. The system also has inbuilt intelligence defrost, where a control function will revert back to a standard reverse defrost, giving full capacity if the load in the space is very high. City Multi YLM is a significant step change in VRF technology, but it's only the outdoor unit that's changed. The wide range of indoor units available are still compatible with YLM, including the designer Zen wall mount units, VRF air curtains and water heaters, optimizing efficiency with heat recovery. All of these systems are compatible, including standard BC controllers, controls, MNet networks. Thank you for listening to that introduction to City Multi YLM, the ultimate heating and cooling solution for your building.